Okay, I'm trying to make this at school. This is going to be 5B, and this is the second in Unit 5 for my astronomy kids. And as you can hear, those main announcements are still happening. This one's going to be talking about the gas giants, or the Jovian planets, and these planets are going to be a little different than the terrestrials, composed mostly of gases. Remember, we're far enough from the sun where temperatures allow gases to coalesce, as well as ices to coalesce into solids or very thick liquids. Primarily, they're made out of hydrogen and helium, relatively small rocky core, plus a web assignment that the kids did today. With the differences between the Jovian, there are a whole lot more things in terms of size and density and moons and speed of rotation, speed of revolution, other things. And if you take a look at it, these are the four Jovian planets. These are ringed planets as well. Jupiter, Saturn, Uranus, and Neptune. Jupiter, the god of gods, Saturn, his father, Uranus, his father, so Jupiter's grandfather, and Neptune, the god of sea. They probably all have rocky cores, and you can see that little brown thing in there. They could be made out of ice, but they're solid. And then you actually have a mantle, and you basically are made out of hydrogen and helium for the most part, and you would fall literally thousands of miles into all of these things before you found a liquid that, or a gas, that was dense enough where you could float. But you'd also find out that it's incredibly heavy. It would crush you. It's probably also very warm, would bake you. But these are the Jovian, or the gas giants. Jupiter is the first one. The most amazing thing on Jupiter is this red spot. It's about 3 times the size of the Earth, to give you some idea of how big it is. Its symbol is a funky looking 2-4-ish kind of a thing, and it's the scepter on the top, or the top of his scepter. Remember these things down here. These things down here actually show you the placement of the planets. So Jupiter's way out here in eccentricity. It actually goes from para to aphelion from this distance as it orbits around the sun. So one side would be the para and the other side would be the aphelion. So as it went around here. Notice how far away it is too. It's 5.2 times the distance between the Earth and the sun. So this distance plus there and there and there and there and there. So Jupiter, funky symbol, shows you the size of the Earth. Diameter, it is the biggest planet. Mass-wise, it is the biggest planet. It has 67 known moons, probably more. It has the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. It does have rings. It actually is 5.2 AUs, a whole lot of kilometers away. The orbital period is around 12 years to go around. Its effective temperature, looking at all the side toward and away, is 148 degrees below 0 C. So it's actually really, really, really cold. First recorded 7th to 8th century, and by the Babylonian astronomers. Giant red spot gives you some idea of how big it is compared to the Earth. Here's a false color of it. This is what it normally looks like, and it's just a big hurricane spinning. As it takes about 9 hours to go around the planet, but it also is spinning. You can see there are a lot of other hurricanes going on, but this is a hurricane that's 3 times the size of the Earth, and it's been there for as long as we've seen Jupiter. Really long living storm. Jupiter does have rings. We didn't know it until we actually had spacecraft. If you take a look, you can see the sun. The sun is on the other side of Jupiter, and as the satellite turned around to look at Jupiter, we actually discovered its rings. But it does have rings, quite an extensive ring system, nothing compared to the next planet, but it does have an extensive ring system. It has gossamer rings, and it has the main ring, and it actually has satellites inside the rings, which are sort of helping keep these rings in place. Jupiter's big moons, Io, Europa, Callisto, and Ganymede, and you can actually see it compared to the Earth's moon, so it actually has moons that are bigger than the Earth. Io, I think, is one of my favorites, called the pizza moon because of its color, and it does have sulfur volcanoes going off. That's what these locations are, but it has sulfur gases going off at times. It does have a magnetic field like the rest of the Jovian planets, so it would have a north and a south pole, unlike some of the other terrestrial planets. And does have X-ray auroras, so it actually does have auroras going off just like the Earth, as that magnetosphere takes in high energy waves, but they're going to be in X-rays rather than visible or ultraviolet like they are on this planet. Saturn, the next planet, this is Saturn's staff. It's a funky looking H. Saturn is the only planet that is less dense than water. You can see it's about twice the distance away from Jupiter and has an eclectic type of, or eccentric type of orbit. Again, perihelion and aphelion. Does have moons that are large, and it has the most extensive ring system of any planet that we are aware. You can see the sun's lighting it up, and the shadow of Saturn is actually cutting out the rings. Saturn is 9.5 AUs, not quite as big, not quite as massive, does have 62 moons. Titan, the biggest moon known, has 30 plus rings, 7 big groups of it. Orbital distance, so that it actually takes almost 10 years to go around the sun. It's getting colder as we go out, still 8th century. Does have a symbol, which we've talked about before, and I don't think I have this. Can I? So let's see. Saturn doesn't have its, doesn't look like it has its orbit and position. Actually, we got it right there, didn't we? Saturn's rings, mostly ice. They're just particles of ice. They're not solid rings. If you actually landed on it, you'd be orbiting with it. If you went in, you'd orbit a little faster. If you went out, you'd orbit a little slower, but you'd be in with all these little ice rings that are out there. And you can see they've got gaps in between the rings. The rings themselves actually have names. The gaps have names. And there are satellite moons in it. You actually just have spokes in the rings. We're not exactly sure what those are. Titan, it's a moon that has an atmosphere, probably has a liquid ocean underneath it. But it's the only moon that does have an atmosphere because it is the largest moon. It has gravity enough to hold gases. If you take a look, we actually have ice. And then we go down, we have liquid water ocean. And then we have normal ice sitting on top of it. Then you have a surface on top of it. Then you have a relatively thick atmosphere going on. And it probably has a silicon type core. But it still is going to be associated with water. Then we go on another planet, Uranus. Uranus actually spins through space like a barrel. Its axis of rotation is basically right along the ecliptic, so it rotates like this. It does have rings. You can actually see it's almost twice as far out as Saturn was, and you can see eccentric orbit. Still has para and aphelion. Its symbol is like this. It's sort of like the sun, except now we're actually saying this is the pole, and it rotates around like a barrel. Not as big as Saturn or Jupiter. Does have rings. Does take almost 20 AUs to go around, 84 years to go around its orbit. It's getting colder. It was not located until 1781 by William Herschel. It does have moons. Miranda is a really funky moon. I don't think I actually put it in here, but it looks like it's a moon that's been trying to be ripped apart. And this is saying Uranus looks like a star. There are rings around Uranus. The wind from Uranus blows at 512 miles an hour. Uranus was explored once, never again. There are dark spots on Uranus, and Uranus is tilted sideways. And it actually makes more sense with the saying if you pronounce it the way it's not named when we talk about Uranus. And if we're going to talk about Uranus, we really need to be in a biology class. Okay, the last planet, looking like it's not quite as far out. It's not twice as far as Uranus. Neptune, I think, is probably the prettiest planet. Beautiful blue color. Definitely looks like a sea. It does have a blue spot, just like Jupiter's got a red spot. And it is probably more hydrogen than helium, but it does have a scepter for the god of the ocean, the sea. 30 AUs takes, where's its year? Takes 164, almost 165 years to go around. It's still getting colder. We're getting close to absolute zero. We're only 50 some odd degrees away. It was not discovered until 1846 by two French astronomers, and there's its symbol. There's the Earth. And then the last thing we're going to talk about is Pluto. Pluto now is a dwarf planet. 2006 it was demoted, and that's one of the reasons is that it's not in this ecliptic, it's not in this nice straight line. It is 39 AUs away when it is para. It is less than Neptune's orbit when it is, when it's aphelion it's 39, and perihelion it actually is even closer than Neptune. We don't have any other planets that cross the orbit of other planets. Pluto is weird. Not very big, not like the other Jovian planets. Its orbit's very strange. It actually does have 39 AUs for para, 30 AUs for para and 39 for aphelion. It's not a gas giant. It seems to be more terrestrial, although maybe not so much rock and more ice, more like a comet. Maybe it was captured by Neptune. Maybe it was knocked off Neptune. But in August 2006, the International Astronomical Union downgraded Pluto to a dwarf planet. Pluto. This is actually an image, and if you go to our G drive, I've got an animation video of this. For some reason, it's got this heart-shaped crater. It's got a relatively smooth surface. Perihelion and aphelion, you can see it's actually, almost 15 million more miles farther away when it's far, or 15 million miles or kilometers closer when it's close. It's eccentric. This is actually, I don't think that's the right number. I think it's actually running around 20%, not 1.6. Oh, I'm sorry, that's the Earth. So you can see 15 million kilometers, where this one is almost twice as far away when it's aphelion than when it's perihelion, and it is 25% eccentric in its orbit. Another problem Pluto has is Pluto's orbit is not on the ecliptic. It does, like I said, actually go inside of Neptune's orbit, but it doesn't cross Neptune's orbit at that point. Diameter, really small. Mass, not very big. It's even less than 20% of the moon's mass. Orbital distance, 39 AUs, but that does have a very eccentric, so it goes 30 AUs when it's perihelion. Orbital period, 246 years. Surface temperature getting closer to 0 K. Moons, it does have 5, Charon actually being its largest. And this is actually the Earth's moon compared to Pluto, so it's smaller than us, our moon. Discovery 1930 by Tombaugh, and he actually discovered it, saw it moving against the starry background, called it a planet, and then 2006, it wasn't even a year old, because it has to last from 1930 to 2006, it's not 246 years. It was downgraded to a dwarf planet. Pluto seen from Charon. Charon from Pluto is going to be very similar to that. And then how big is Pluto? Pluto is smaller than our moon. It's bigger than some of the other objects we found out that are trans-Neptunian objects. And here's another picture where we actually threw in, there's an asteroid. The moon is not in here, but we have a whole lot of objects out there. So Pluto, we've actually found Xena, which is bigger than Pluto. So if Pluto was a planet, we'd probably have to make Xena the planet. And then some of them are actually still named after the year they were discovered, as well as some are actually named after gods. Okay, there's the stop. Thanks for stopping by. Adios.